Welcome to the first official X World session of the day. Of today. It's my great pleasure to introduce Marcus Ransom. Many lives you have lived. Most recently now with Jamf.
Yes.
Podcast Hall of Famer. Podcast impresario. I don't know. Well, good. All right. So my good friend Marcus Ransom is going to walk you through some of the declarative device management. Who's using DDM? Yeah. Who wants to do more DDM? Yeah.
There we go.
So do we. Yeah. So hopefully you'll learn some really great stuff from Marcus. This will be a great session. If it's not, blame Marcus. And with that,
always best to blame me. Thank you very much, Joel. As I said, we're going to be looking at declarative device management. I'm going to be taking the approach of what declarative device management means for us as device administrators. So we're going to start with a little bit of history, then go through the basics, and then most importantly, look at some examples, and then have a little bit of a look into the future and talk about what we'd like to get. So before MDM, there were many ways of managing Macs. So none of the things we're going to discuss today really would have existed if it wasn't for the innovation delivered by a whole bunch of tools. So, what sort of things were people using for managing Macs sort of back in the day? I'm thinking about things like At Ease. Did anyone use At Ease? Yeah, Dave, Admit Mac, FileWave, Radmin, LandRev, Apple Share IP. Don't forget things like Monkey, Mac OS X Server, Workgroup Manager, Deploy Studio, Profile Manager. Anything else I've forgotten that people were using? Yep. Yes. Yeah. Workgroup Manager. We learned a lot of things from Workgroup Manager. So in 2010, Apple released mobile device management. And so we can see here they've been evolving that protocol, introducing many new features that we may have whinged about at the time, but I know, I've grown to rely on these enormously. So, what sort of things here did people find were really useful in the evolution of managing devices? I know myself, device enrollment program, now known as automated device enrollment, that was a really big change for the way that we would, manage devices, onboard devices, getting away from imaging. We're not allowed to talk about imaging anymore. What sort of things did people find were really changed the way they managed Macs on the things that we saw here? Device-based volume purchasing, absolutely. Yeah, as somebody who once had to help create, I think it was 900 personal Apple IDs, no longer having to do those sorts of things was, and having a protocol and a framework that allowed us to be able to do things much more easily and in a supported way was amazing. So before we get to what else came in 2021, let's look at how the basic MDM protocol operates. So we've got an MDM server and we've got a device. APNS is the broker that allows them to communicate. Now, for enrollment of a device, there's a whole dance that goes on here. There are a lot of really good presentations out there that go through this in detail. Once the device is enrolled, the MDM server tells APNS, I have something I want this device to do. The device is checking in with APNS. It checks in. APNS says, the MDM server has a command for you. So it reaches out to the server, gets that command, gives a response back, queries the state, we get responses and we get commands going backwards and forwards. There's a lot of network traffic required to do fairly simple things. And most importantly, it is all initiated by the server. The server is telling the device what to do, what information it needs, and the device is responding. So to get around that, most device management tools have an agent in Mac OS that is doing the heavy lifting, doing all sorts of other things that the MDM protocol isn't able to do. So we get to 2021, Worldwide Developers Conference, Anvil drop. We get declarative device management announced. At this stage, it was only for user-enrolled iOS, that BYOD separated business and personal case. There weren't a great deal of devices actually using that at the time, which was really good because it allowed the MDM developers to be able to understand how this works and try things out without having an impact on our entire fleet, to be able to do that in a safe way. 2022 introduced declarative device management for all enrollment types and all device platforms. So this is where we saw several MDMs implementing the status channel predominantly, and started integrating those status items that I'll get to in a second to get information back from the device as to what was happening. 2023 is where things got interesting. So there is a huge amount of information out there, other presentations around the protocol and how things work. So if you're keen, I suggest watching those videos. I'll have some links at the end. So that focuses on the protocol that is there for MDM vendors to implement. And I think this is an important thing to understand. The protocol is for the vendors to implement. As administrators, it's there for us to understand how that works and how we can use that in the workflows we set up for managing our devices. So Apple is also, as we know, very deliberate with language. So this particular change that was between the sessions at WWDC in 2022 and 2023 is really worth paying attention to. The focus of future protocol features will be declarative device management. And then last year, the focus of new protocol features is declarative device management. So new features moving forward, we can expect them to be declarative device management. So we need to understand how this works and how we can manage our devices. So the MDM providers have all started implementing this. And probably the biggest area we've seen this is scheduled OS updates, because updating the operating system is something we as admins have had a lot of fun trying to implement. And Rick Goody has got a session later on that focuses on that. It's got some really good information there. So Apple used some language to describe mobile device management. They said it was imperative and reactive. So imperative means absolutely necessary or required, unavoidable. So an MDM command tells you exactly what the device needs to do. Do this now. And so it's reactive because you need to know when to send that command to the device and for that to happen. So who remembers MCX from Workgroup Manager that we discussed before? Yes. So the manage once option, where you could send a configuration out to the device, giving a default state, but the user could then change things the way they wanted themselves with things like, desktop backgrounds, docks, those sorts of things. MDM is kind of the opposite to that in a way. Yeah. So declarative device management, Apple says, it is autonomous and proactive. It knows when to do the things without needing the MDM server to remind it, please do this now, or to be told at an exact time. It can make those decisions itself. It can react to things on the device. So, a very simplistic overview. Declarative device management takes the load and responsibility away from the server and reduces that constant network connection. So the server will send a configuration to the device that tells it, things that it needs to implement, when it needs to implement them, and information it wants to receive back. So the device will send information back saying, this changed, or I did this, or I did this because this happened. So the server is not having to sort of come up with a cadence that it needs to constantly query the device to know what is happening and then make decisions and try to perform, as we know, some complex calculations to then try and work out how to send a change or a configuration out to the device. So as we can see, it's autonomous and it's proactive. So other words I've heard used to describe this is statefulness or idempotent, things that people have seen with configuration management tools that they would use on other platforms. So Apple's done a great job of documenting the protocol. The challenge for vendors is how to integrate that protocol into our existing systems and workflows and those interfaces that help customers to begin that transition into the new way of managing devices. That's something that's really important to understand. Declarative device management is a protocol in the back end that allows device management tools to be able to use that information to create those workflows and experiences that we all want. So there are two main pillars to declarative device management. We've got declarations. So These describe the state or configuration of the devices that it needs to meet. And then we've got status updates. That's the device communicating back to the server information about what's going on, so the server knows the state or the condition of that device. So I'm not going to go through every single example of the declarations because there's a lot of them in the protocol, but you can see there what the operating system is going to understand with declarations to be able to do certain things. So MDM communication, as we know and love, is almost entirely XML, whereas declarative device management is JSON. So if you're having a look at what's going on in your servers, understanding the differences here. So a declaration has 3 required pieces of information. Sorry. The type of declaration. So that's the protocol, which piece of information that the operating system is going to understand are we dealing with here. We've got a unique identifier that we can use to talk to other declarations and management frameworks, and then the server token, so the device knows to trust the declaration. And the last part is the payload, and that's where the information you'll see a little bit later. There's some required and some optional data that goes in there. There are 4 kinds of declarations. So configurations, think of them kind of like configuration profiles. They're not too dissimilar. So, you can use them for configuring things like, passcodes, software update, those sorts of things. Assets are references to data that the configuration will call on. This is where declarations start to get very different from configuration profiles, and we'll have a look at that in a second. Activations are a set of configurations for a device to apply atomically based on criteria that you can set, and management declarations are used to convey static management state information. So let's have a look at declaration configurations. As I said, they're similar to configuration profiles. We've got a payload key representing data that's pertinent to the declaration type. So in this one here, we've got a software update declaration. We get an ability to put in a URL that the user can see to find out about the software update. We've got the required target OS version and target local install date, and then the optional build version. Asset declarations allow specific objects and values and items to be used across multiple configurations. So think about the network configuration payload, where if you had a certificate that was required for your network, that needed to be in the same configuration profile. Whereas with declarations, you can actually separate those and you can have a one-to-many relationship. So you could have a certificate on the device and then individual declarations could reference that certificate rather than them all needing to be in the same configuration profile and having to do that dance that we've all done of trying to, renew a certificate and not disconnect from the Wi-Fi, not disconnect from the Ethernet. Lockdown was a really good time to renew your network certificates, VPN certificates, those sorts of things. So as we can see here, there's a one-to-many relationship, and they can actually get quite complex because you can have multiple assets referencing multiple configurations referencing multiple assets. So activations, these are the things that will tell you which declaration on the device is going to be active based on a set of criteria. So this allows us to push a declaration out to a device and have it there primed and ready for when the device is in a particular state when we want that to be active. For example, it's updated the operating system. So we've got an activation declaration here that's saying 2 of these 4 configurations apply when the device is on iOS 17. So we've got a device here on iOS 16. So we get 2 of those that are active, and we get 2 that are not active because they're in this activation configuration saying need to be on iOS 17. We go and update the device. Those 2 configurations automatically apply. The server does not need to tell the device, oh, now that I know you're on the new version of the operating system, now apply these configurations and the complex grouping required to deliver that. So management declarations, they're used for sort of static information about the management state, information about the server. We haven't seen a lot of that in production yet, but this gives the vendors opportunities to do things in the future. So let's have a look at the status channel. So this is new communication mechanism and allows the device to proactively update the server with new information about itself. So we may have, a state or a configuration on the device that's not active. The user changes something on the device, the status channel tells the server about that immediately. So we don't need to set up that cadence of inventory on the device, trying to work out whether the configuration, what we can see in our console, is up to date based on when the inventory happened. That's going to happen immediately. But we can also send information to the device and say, I want to know when this particular configuration activation has happened. The user does something, it changes the activation on the device, and then that goes back to the device. So, we'll look at an example of this in a second. So with the status channel, we're able to subscribe to certain events. So, we don't have to have everything in the protocol because the MDM vendor needs to build into their workflows how to interpret that data, how to express that data back to us as administrators, and give us the mechanisms to be able to include that status information into our workflows. So the status of declaration is always reporting to the server when it's changed for a declaration. So you send these subscriptions out for information outside of the declaration, but if you've sent a declaration to the device, it is automatically going to receive status updates when that changes. And they're also incremental. So unlike an MDM inventory, where that's capturing all of the information about the device and sending that back to the server, and then the server is having to calculate that difference between the last inventory and the new one, the status channel is only reporting back what's changed. So once again, we're removing the volume of network communication that's happening. We're only finding out about what is relevant. So this status update here is saying this Mac is on 14.3.1. The user goes and updates it. They just get a status response back saying 14.4.1. They're probably going to get other status response with build version, other sort of information about the operating system. But you can see, rather than a full list of everything, very simple information, very easy for the MDM device management servers to actually interpret that information. So it's all great in terms of protocol and theory. Let's have a look at what this looks like in action, what we've seen implemented out there, and how we can use this and why this is important. So what can we use this for? So, conditional access. We've been talking about security and making decisions on the state of a device as to what they can have access to. So let's look at an example of passcode compliance. So we are going to insist that devices that get access to corporate information have to have a 6-digit passcode. So we've got a phone here that's got a 4-digit passcode. So we push a profile out to that saying you have to have a 6-digit passcode. If we just use the fact that we've sent that profile out to the device, we can see here the user is told they need to change to a 6-digit passcode, but they've got 59 minutes. So just sending that profile to the device doesn't tell us that the device is now compliant. And we can see there, the status channel has come back and has said the device is not compliant because we've got a configuration profile and it says 6 digits, but the device does not currently have a 6-digit passcode. So you can use that information to say the user is not able to access, their email, they're not able to access corporate data unless they have gone in and performed that action to update the passcode. And we can see that the inventory status of the device has not changed because this isn't an inventory update. MDM inventory updates generally once a day unless you force one. So you potentially got 24 hours where you're not really able to make decisions about devices with MDM. But in this case, the user goes and does what they need to do, updates their passcode, and then we get the information back saying, that the device is now compliant. So the next example I'm going to use is software update. I'm not going to go into the previous challenges with software update. I think most of us experienced those. Once again, Rick is going to be giving some really awesome information about how to approach that. But this is a really good way of keeping your software up to date on a Mac and iOS. So we can see in the documentation, this is the declaration configuration that can be sent out to devices. And we can see we've got some required keys and some optional keys. So in Jamf, we have implemented this in our new software update section, currently in beta. Beta does not mean that it's not supported. Beta means that this is going through evolution and is changing. So it is 100% supported, and we have lots of customers using this and having really good experiences. It's really important to understand, though, that there is only one option here that leverages declarative device management. There is only one declaration at the moment that allows you to manage software updates. The others are still using MDM, and your mileage may vary with those. So to do this, we select an install date. That install date is local time on the device. So if you've got devices that are in different time zones, you're able to set a time of the day that makes sense for that deadline to update software on the device. And then the operating system takes over once that declaration is on there. So it is going to look after the notifications and all the mechanisms to keep the device up to date. This is something that's really important with declarative device management. And I see this as being one of the really powerful fundamentals. I've always found that whenever as an admin, I've tried to insert myself into the software update workflows, that's when things start to catch on fire and things go wrong. The more you can let the operating system do the things that it's designed to do and just provide these signals to the operating system, that's when you're going to get success. So we can see here, in Jamf, we are using a combination of MDM and declarative device management to get this workflow to happen. So we've got these concepts of plans. So whenever you, in software update, you set up that decision as to what you want to do with your devices, it will create a plan for each device in the back end. And we can see what's happening here. So the first thing it's doing is scheduling an OS update scan. So you'll see an MDM command going to the device. The device will check in with Apple and see what versions of what updates are available to it. 5 to 7 minutes later, it will get an available OS updates MDM command. Now, before I understood this workflow, I was sitting there seeing in pending the second MDM command going and trying to send blank pushes, trying to send other configuration profiles. I just needed to be patient. Go and get another coffee, come back, and then you can see that that's gone through. That's when the declaration is configured. So once the management server knows which updates the device can see, create that declaration and send that declaration out to the device. And that's when declarative device management takes over. So how does this work from software updates? So that deadline that we've set, 30 days before that deadline, you'll start to see in the settings software update user interface that there is a software update pending. 14 days before that deadline, you'll start to see those notifications coming up for the user daily. Do not disturb will stop those notifications from coming. 24 hours before that deadline, they will start coming hourly, and most importantly, they will ignore do not disturb. So it's very hard for the user to not see those notifications coming through. And then 1 hour before that deadline, they will start to get a 60-minute warning, 30-minute warning, 10-minute warning, and at 60 seconds, they'll start to see a countdown saying that this update is going to happen, and there's not a lot that the user can do to get out of that. Now, if the machine was turned off, not connected to a network, was not able to receive that declaration, if they get that declaration after that, that deadline, the device will just treat it as if it's 1 hour beforehand, and that workflow will start going through again. So we can see here what they see on device in the user interface there. Most importantly, if you go into the profiles section in system settings and go to the MDM profile, at the bottom there, you can actually see the contents of this software update declaration. So you can see on device that that declaration has arrived on the device. Also interesting, VARDB software update DDM state persistence.plist actually has information about that declaration that's gone onto the device. Now, I've seen some people create some extension attributes using things like Swift Dialog to be able to provide additional notifications to the user based on this plist. I expected that plist to be protected by SIP, by System Integrity Protection. It's not. An administrator can write to that plist. So keep that in mind if you are using that for any sort of information gathering, is that apply a level of trust to what's in that file based on the fact that it can be modified. It does refresh itself. I wasn't able to find any particular cadence that would refresh itself, but it would. I'm interested to find out where that goes and what happens with that. But really interesting to see what we can find on device. So in terms of, as an administrator, knowing the state of what's going on. So a lot of people trying to understand what's happening to their devices. At the moment, the API gives you an enormous amount of information back. So you can actually use this particular API, Manage Software Updates Plans, to get a list of the plans that you have active at the moment. Here I've got 2. We can get the unique ID of a particular plan for the device that you want, and then we can drill down into there. And so we can see here, the plan ID, exactly what it was that it was doing. The download install schedule means it's declarative, which version, what the time was. But most importantly, down the bottom, we've got these state. That's the status updates coming back from the device saying what is actually going on. So if you're trying to troubleshoot what's happening on your device here, you can see there's a whole bunch of different statuses that you get. It's accepting the plan, it's starting the plan, it's doing that schedule OS update, it's waiting for the response for that, it's collecting them, then it's scheduling the declaration, it's waiting for that to start, and then it's just collecting the status, and then the plan is completed. I'll have a link in the end to this documentation, so you can look through. We've documented all the various different states. There's also errors in there, which is really good to know, because for those of us who have been trying to manage software updates, if or when something goes wrong with software updates, it's good to know why, what happened. So we can see here things that may have stopped that declaration from working. The device management has sent the declaration to the device, but it didn't work. It's Apple Silicon. There's no escrow key. It's using the Bootstrap token to try and authenticate that update, but it didn't have one. It's not supervised. There wasn't enough disk space. The specific version that was sent down, the device has decided it doesn't want to install that version. Apple software update lookup service error. Systems sometimes don't work or aren't available. It was the proxy. There was a network issue. Unable to find updates and out of retries. It's going to time out. This is one that's interesting. Declarative device management software updates not supported for device or version. It was running Ventura. You can't use this to upgrade a device from Ventura to Sonoma. Hopefully, I'm guessing we'll be able to see that being able to be used going forwards. This particular API, I don't think is documented. You can actually drill down from the ID into events, and you can actually see that flow for that device of all of the events that have gone through. And that gives us some really useful information. So we can see here, especially with epoch time in there, so you can start to calculate when these things happened, the plan getting created, accepted, the plan starting, scheduling those operating system update scans. And then we start to see, once that declaration is in place, the declaration's coming back. So this is a status report saying, I've got that declaration. This is a version of the operating system I'm going to update to, and this is the deadline based on the local time on the device as to when that's going to happen. And then we can start to see, once we get closer to that deadline date, that the device is downloading the update in the background. It's preparing the update in the background. It's installing. And then once that installation is finished, we can see that the verification is completed. That's been completed. So going through all of these statuses in that declaration, you can get a good understanding of what's happening on the device. That's in the API currently. Some tips. Software update declarations and MDM commands and profiles can coexist, but it's important to understand what that looks like. Software updates enforced by declarations will always take precedence. So at Jamf, we're using those 2 MDM commands to decide what version to put in the declaration. But once that declaration is down on the device, sending the other MDM commands, the force update, the machine is not going to respond to those updates. Deferral profiles. If you've got a 60-day deferral profile on the device, but you tell it to update to a version that was released yesterday, it is going to do what the declaration says, not what the deferral profile says. Also really interesting to work out what's happening on the device. Ross Matsuda has got this great blog post. Once again, I'll have a link, a QR code later in there in the slides, that is going to show us what we can see on device. So the install log has some really interesting information in there. So, start out by having a look at the install log on a device and just filtering by DDM and seeing what you can see. But it gives you some interesting artifacts that you can drill down into. So we can see here, these are the notifications that the user received. So once again, user saying, I did not see notifications, this did not happen. We're not saying that they did see the notifications, but we can see here that the device did provide those notifications. Maybe those notifications always happened at the time they were getting a coffee or when they were looking somewhere else, but we can see that the device did what it was told to do. Here we can see scheduling the deferral, scheduling the declaration. So we can see in the logs here that that declaration was received by the device, the information that came through. Other interesting things here where we can see the cadence of those notifications. So we can see here the declaration comes onto the device. It says, oh, it's within 24 hours, so I'm going to move to a 1-hour cadence. I'm within 30 minutes, those sorts of things. We can even see at the end of that 60-second countdown, that forced update. So there's a lot of information you can capture from your device if you're trying to troubleshoot why things didn't work the way you thought they were going to work and understand what the device thought it was told to do or how it interpreted those commands, what happened, what might not have happened. So let's talk about the future. So this slide from last year, Apple was very clear that this is going to be important for the way we manage devices. It's exactly 1 month, depending on time zones, to WWDC. So what will we see? I'm excited based on what I've seen already. It's been really awesome to see the MDM vendors unravel what declarative device management means, how that can be integrated into the overall device management solutions. Software update really has been the primary focus for almost everyone, but it has been great to see other examples of things like the service configuration files and other things. As I said, the majority of the work is for the MDM vendors and Apple to deliver, for us to work together and make sure this is a really good experience for administrators. So what can administrators do? So this one was really interesting. You can install declarations manually on a device, but there are several caveats. It can only be deployed to a device that is not enrolled in MDM. So this is not a solution where you can say our management supports these declarations, but I want to use this one, so I'll just send some configuration profiles out. This is a really good way to test things. Not all declarations are supported. So the software update one, for example, I don't think is supported. But when new things come out, you can actually create base64 blobs of those declarations and put a declaration in a configuration profile and test that out on a device. So you can provide feedback to Apple and say, hey, this is great, but maybe we're finding some conflicts with things, or we would like to see it do this as well, or be able to say to your vendor, this is awesome, we'd love to be able to see this for these reasons. This will allow us to buy this many devices. Those sorts of things that will give vendors an understanding of what this is going to mean and how to prioritize it. KMF DDM is an open source declarative device management server that can be used with the open source MDM servers, micro MDM or nano MDM. These are also really useful tools for exploring how that raw protocol works. They don't have a GUI, they don't have the workflows put together, but if you're wanting to see what a artisanally handcrafted declaration does pushed out to a device, these are really good ways of testing and understanding how things work. Once again, especially useful for providing feedback to Apple. So what are you looking forward to? Like, what sort of things are people looking forward to being able to do with declarative device management? Has anybody got any strong opinions? Cameron, you always have strong opinions.
I like, when an application is installed to actually get, back of the
Yeah, so Cameron was saying he'd love to get feedback about an application being installed. Absolutely, that sort of information would be amazing. Are there any other things people would love to be able to see? Rick?
In the past, when Apple released something, so I'll use PPPC as an example, and we had changes from Big Sur, what it could do, like screen sharing, mic control. There's always this, right, you've got to create a smart group to say, right, don't deploy this until this. Because if you deploy a profile before it's actually available, it's not actually going to take it when it is available. So is Declarative going to help with that?
It should. The declaration can exist on the device. And my understanding is even if the operating system doesn't know how to interpret the particular declaration, if the activation has said, ignore this until the machine is in a state that it knows what to do with, that activation will take over that logic, which is great. So you know that your fleet is going to be updating to a state where they can understand all of that stuff, push everything out beforehand, and we don't have to worry about that.
Yeah, going through that dance. Yeah, it's like, is it? Yeah, wait, no, okay, let's go.
Yeah,
just get it ready, pre-prepare, and let people upgrade.
And I'm interested to see if DDM could become monkey.
Yeah.
As in do everything, deploy everything, have that defined state. I want the machine in a defined state.
There was in the most recent release of declarative device management some application control in there. There were some very specific requirements about how those applications needed to exist in terms of needing to be in the applications folder, not being able to be multiple packages, those sorts of things. But I think you're right, where we're looking for that opportunity for it to be able to do all the use cases, to be able to have a consistent way of deploying applications and managing applications, rather than being able to use it for a small subset of that. But yeah, that's absolutely something I'd love to be able to see as well. As I said, some resources here. So I did not invent declarative device management. I certainly did not understand it on my own by reading the documentation, but there is some amazing information out there. This is the same QR code, but very much want to thank some people who really helped me on this journey and understand how this all works, so I could understand how to explain it to people. Especially want to thank Charles Edge for encouraging me to be curious and want to go down the rabbit holes of items like this. Thank you very much.